applied maths and physics at Queen's, and then keeping things royal, went to King's College London to do a PhD working on heart models like what you can see up here in the top right corner, which I continued that a couple of years in Austria before I came back to London to work at the ASI as a software engineer. ASI, which you may have heard of, is we're a data science company based in London. We basically provide artificial intelligence services. That's partly a consultancy, which is work with a wide range of organizations from the Home Office to airlines. But the part that I work on, which is a major part of the company as well, is developing our data science platform, which is Sherlock ML. While in Sherlock we use a wide range of technologies, like including React and Scala, Python remains like a core part of our of what we do, both from the data science. It's the primary language that we use for doing our data analysis and modeling, but also in building Sherlock. So the main point of today's talk is to talk a bit about how you do like large data analysis in Python. So in some applications you might have many terabytes of data that you want to process, but of course using like traditional techniques, if you just have doing something on your laptop or on some small server in the cloud, you're going to take a long time to churn through all of that data. And so while you might end up with, you might enjoy having your feet up, drinking a cup of coffee, it's going to slow you down, and you're not really going to be able to like iterate quickly and like improve on the models that you're building. So ideally what you'd like to be able to do is to have a large number of computers which can all work on your problem together and get your tasks done and get more done in the day. And so one tool that you can use to do this is Apache Spark, which I'm sure you've all heard of, but essentially Apache Spark, in very, very broad brushstrokes, allows you to orchestrate some set of computers which will do some useful work for you. You have some driver program which is able to orchestrate these workers to do some kind of task. They can read from some external or internal data store and write results back to it, and Spark orchestrates communication of all these components between each other so that this big cluster of computers can work on your big problem, big data crunching problem in concert. There are a number of ways that you can run your driver program, but today I'm going to be talking about using Apache Livy, which is a REST API server that can sit on top of your Spark cluster and manage Spark sessions and running your code inside the Spark cluster. The nice thing about Livy is that because it provides this REST interface, it means that you can have your Spark cluster running somewhere, potentially managed by your company's very skittish IT infrastructure department. And by providing relatively simple access, you can run your code from outside without needing to do too much setup. And so, yeah, we're going to be talking about using either Python or particularly using Jupyter to run code inside a notebook that's outside the cluster, but orchestrating Spark being done inside. So I'm just going to like quick show you in a real notebook how you can do this. I'm going to connect to a Spark cluster, load some data in, do some basic data analysis, show you how you can get data out into your notebook in order to do some more analysis or some plotting. I'm just going to very quickly show you that there are some nice machine learning tools built on top of Spark, and also outside of notebooks, how you can also use the connect with Apache Livy to do like useful work. I'm going to demonstrate this using this Amazon product reviews dataset. They have published an open dataset on S3, which everyone can use with some license restrictions, which has 130 million product reviews. So if you imagine these reviews that you see at the bottom of a product page on Amazon, where people write, "Oh, this was terrible," and like give it 1 star, or the opposite, that's what we're talking about here. I've just before the talk started up an Amazon EMR cluster. EMR is a nice service that Amazon provides to orchestrate a Spark cluster relatively easily once you figure out all of the right command line flags you need to give it. Part of my demo is already slightly broken before the talk, so let's see how it goes. But the core of what I'm talking about today is using this really fantastic utility some guys that have written called SparkBillMagic. This is you can just install this through pip so that it's available on your Jupyter notebook. There's a GitHub page. But with that, I'm going to go straight to my demo, which I have here in a notebook. So can everyone see that all right? Cool. So the way that you get SparkMagic working once you've installed it on your server is to use use this load ext magic command. So that loads SparkMagics into your notebook and provides this magic command Spark, which if you run with the question mark, you can see some documentation. So there's a bunch of different features here for like creating and managing your Spark sessions and for running your code. But to get started, what you need to do is to use the Spark add command. Here you need to give it a name. You choose a language. You can run your Spark code in Scala, Python, or R. Since this is a Python conference, I thought Python seemed a sensible choice. And also choose some like authentication mechanism and like the URL of the Livy server. In this case, I'm just connecting to the cluster with some SSH tunneling, so there's no authentication, and I'm just connecting. That's why it appears that it's on the local machine. But I'm just going to run that. That starts creating that's talking to Livy to create the Spark session. That takes a few seconds. Once that's done, then I can run this Spark info command to see information about the Spark sessions that SparkMagic is currently managing in the Spark cluster that I've connected to. Just while I'm waiting for that to run, you can see that there's extra commands here like deleting a session and cleanup deletes all of the sessions that you've currently connected to. So you can, while in this while in this talk I'm just talking about the situation where there's only one Spark session being managed, you can have multiple ones running at the same time with different languages and so on if that's something that's useful to you. But here you can see that my session is successfully completed, and then whenever Spark info ran, I can see the names of the sessions and so on. And SparkMagic does provide some Jupyter widgets and stuff that you can load to get a slightly more interactive view on this information, but I find it most convenient just to use these magic commands. So once you've got your session running, then you can use this $sign Spark cell magic command. And what this does is then whenever I run this, all of the code in this cell, instead of being executed in my local Python interpreter inside the notebook, this gets packaged up as a string, sent off to the Livy server, where it gets executed, and the output is then retrieved and displayed as if I had run it in this cell. So if I run this here, you can see hello world is printed. But just to convince you that this is in fact different than if I'd run it in a local cell, here I've got two cells with essentially the same code, one of which has the SparkMagic and the other one doesn't. You can see that I'm running locally in the notebook. I've got Python 3.6.5 on this host, but in the Spark cluster, it's running Python 2.7 on a different host name. That's not very useful, but so let's just move on to actually loading some data into this Spark session. PySpark provides this Spark object inside your interpreter's namespace for you, and this is the principal way that you kind of start your data analysis pipeline. So specifically using spark.read, here I'm reading a Parquet format data from this Amazon product reviews data set like I described. I'm reading that from S3. You can read large data sets from S3 quite quickly. And I just can run that cell to create the data frame from that data set. And that takes maybe just a couple of seconds to run. An important thing to realize if you're ever using Spark, and I'm only going to give a very cursory kind of talk about like a bit of information about how you actually program in Spark in this talk, but the important thing to know is that Spark data frames are lazily evaluated in the sense that whenever you apply some transformation on it, that data isn't actually computed yet until you do something in your pipeline of operations to actually collect it. That is an important thing to bear in mind whenever you're writing your code, but the reason that this ran just in a few seconds is because the data frame of 130 million product reviews hasn't actually been loaded yet. What you can do though is you can print the schema of the structure of the data frame without actually having to evaluate the contents. This is because if you have some data frame with a numeric column in it and you multiply that by 2, Spark is able to know that you will have a numeric column in the output with some particular name without ever actually evaluating those values. So my first kind of tip, if you're trying to do some kind of interactive data analysis with Spark from a Jupyter notebook, is to have a look at this print schema method, because whenever you run it, it'll tell you the structure of your data, and you can apply your transformation, do print schema, and it'll evaluate just like that without actually having to do any computations. And so here you can see from this Amazon product reviews data set, there's quite a lot of information here. The most useful things for me, maybe thinking about doing some analysis, is the star rating, the number of stars that someone gave whenever they reviewed their product, as well as like the body and like title and so on of the review itself. And so you can imagine maybe doing some kind of like sentiment analysis on this, where you use the text and also the star rating to like train some kind of supervised problem where you try and predict how well someone felt about the product based just on the text. Yep. So just moving on, like another useful feature whenever you're doing this interactive analysis is to use the ability to cache data frames. So as I mentioned, Spark data frames are lazily evaluated, and which means that very often, if you do the same, have a long processing pipeline where most of the steps are the same, you run it twice with a slightly different transformation on the end. In many situations, Spark will go back and reevaluate the whole pipeline. Whereas you know as the programmer that actually I just want to play about with that last little bit, and so I want to tell Spark, please keep the previous step in memory if you can, and you can do that using this cache feature. And so here I make a new data frame df cached, which is basically the same content as my original data frame df, but with the difference that every time I do some processing with df cached, it'll try to keep it in memory, which it wouldn't have done in the original case. Cool. So at this point, I was planning on switching to another notebook where I'd already so I've done something here to force Spark to actually load that into memory. That'll take like a couple of minutes because it's a very large data set. So I'm just going to switch to this pre-prepared notebook where I've run all of the cells previously. So here, now that I have that data frame in memory, I can do some basic analysis on it. And so here, just to do something very quickly, let's say we want to count in the whole product review data set the number of times each star rating occurred. So you can have a star rating of 1, 2, 3, 4, or 5. And so if you do some kind of group by and count each of those groups, here I can view the result of that. And so you can see that actually the reviews that people give to Amazon products on Amazon is quite it's quite different based on the different categories. Something like 80% of the reviews have a 5-star rating, and the other, and even between the other categories, it's fairly unbalanced. So here you can see that again on this data frame that I've computed the counts of the star ratings. I've used the print schema again, and also this .show method, which just prints out a little ASCII table showing the results of my computation. This, again, bearing in mind that this code is being evaluated on the remote server, this is just some textual output that's being generated when calling .show on the Spark inside the Spark session, which then SparkMagic is retrieving and displaying here for me. But let's say I want to actually, plot this, not just print some like ASCII table. What I want to then be able to do is to retrieve the contents of this Spark data frame, or when evaluated, back into my local Python notebook. And so to do that, you can use this Spark -o magic, where you give it the name of a Spark data frame in the session. It'll evaluate that, retrieve its content, and put it into pandas data frame inside my Python notebook. And so now I can get this, now I have this pandas data frame of the same name, and I can get, do things that I would normally want to do with the pandas data frame, like plotting and so on. So just to give you some idea, if I'd shown this directly, once I've actually loaded this into memory, doing this actual like group by and like counting and so on happens in like less than a second. Because once it's already in memory, just doing this aggregation on all of the workers of the cluster that I'm running is quite fast. And the main reason I'm not showing it now is just because of the data load time. Yeah, so once I have that pandas data frame, then I can do something nice with it, just like making a little bar chart. And so here, this is like much more instructive to see the different sizes of the different categories by star rating. So moving on a little further, as I mentioned, there are good tools for doing machine learning in Spark. There's this Spark MLlib, which has a lot of kind of common feature engineering tools and models that you might want to do in a machine learning project at scale. And so here I'm demonstrating using this tokenizer, which takes some text and breaks it up into its constituent words. And the pattern for these components in Spark ML is that you typically construct the actual like transformer itself. You give it some inputs. In this case, I'm defining what the column name in the input data frame is going to be that I want to split into words, and you define like what the output column name is. Like this will cause, in this case, a new column in the output data frame called words, which will contain like an array of extracted tokens from the text. And then once I've constructed this tokenizer, then I just pass my input data frame into the .transform method of the feature generator in this case. You can chain all of these together with pipelines, and it's quite a nice. I'm not going to go into much more detail here, but I'd encourage you to have a look at the Spark ML lib documentation to get an idea of what the possibilities are. So with that run, again, this takes a little bit of time to run, so I'm just going to move on past that. I can, let's say, just define a Spark function here that counts the number of words, give in a list of words, and produce this numwords a new data frame with a numwords column. In this cell, then I can do some kind of aggregation of that because I want to say plot some kind of histogram of the distribution of words, and again use Spark -o to retrieve it. And again, once that's run, then in a couple of minutes I can analyze all 130 million product reviews and plot this like distribution. So you can see that there's like quite, as you might expect, quite few reviews of a very long length. I've clipped it at 2,000 here just to give a more reasonable scale. It goes a bit further. Yeah, they're all, the number of the reviews are all quite concentrated at quite a short length. So yeah, that's a very quick overview of like what the possibilities of doing some interactive analysis inside Spark are from Jupyter. If you want to use it from outside Jupyter, then you can use this PyLivy library, which is implemented by myself. You can find it on GitHub and install from pip. And essentially what this allows you to do is provides this Livy session object, which you can use to connect to a Livy session, to a Livy server. And inside this context manager, it'll create like a Spark session and tear it down whenever you're finished. And then similar in a very similar pattern with the SparkMagics, you basically provide it like snippets of code to get dispatched to the server to be executed, and any result is returned back to you and printed out. So yeah, if I run, for example, df.print schema, then any output printed as standard output will be retrieved and displayed in the whatever Python script that runs this. But you can turn that off if it's advantageous. You can also, just like with the cell magics, provide multi-line snippets. And in this case, using this ddent function from textwrap is nice to allow you to have lay your code out slightly more elegantly. And finally, similarly to this Spark -o feature in SparkMagics, you can use this .read function to evaluate the contents of a Spark data frame and retrieve it back, and it returns it back to you as a pandas data frame. And so with these kind of features together, you can start building some more cool stuff. So with tools like Plotly Dash and using PyLivy in addition to something like Python RQ, then you can like build like a nice little app with only writing Python. And I was able to do this in a couple of days this week, putting together all of these various components to build like a nice web app that you basically get a button that you can click that will go and run some extremely large like Spark query for you. And so if everything has worked, oh yes, it has. Okay, so this is my Plotly Dash app that I've written. I run a query and it's dispatched a job into my Python RQ worker queue, which is running in parallel. It's running this Livy session code in order to evaluate a Python snippet and retrieving back a couple of pandas data frames. This takes like 3 or 4 minutes to run, so I'm just going to jump ahead to what this would look like whenever it's finished. It'll update itself, show the Spark query is complete, and you get this nice like Plotly graph where here I've split those counts into like verified and unverified, meaning like whether or not a review was by someone who actually purchased the item or not. And so, yeah, you can see some interesting stuff. For instance, like here I've like normalized both of the distributions. So you can see that actually it seems that people who haven't bought the product are more likely to write longer reviews, which seems a little unusual to me. Oh, what have I done? Yeah, I've zoomed in accidentally. But yeah, because this is like a nice plotly graph and you can like interact with it and view around and look at some of the values and stuff. So yeah, I think this is quite a nice application of Python, like bringing together these various like worlds of like building web apps and plotting, and also like interacting with things like Spark to run like analysis on very large data sets. Cool. So that's all I have to talk about. Thank you very much for your attention. I would recommend, if you're interested in learning a bit more about how to use Spark, these two resources at the top here, basically the Spark documentation, the main documentation, but in particular looking at the machine learning libraries homepage. You can see there's quite a long list of like features that they've implemented there. SparkMagic and PyLivy are good utilities if you'd like to apply some of this stuff, and of course if you're interested in having a look at sherlockml.com, I'm happy to talk to you afterwards. But otherwise, thank you very much for your attention.
Time for a few questions, yeah?
When the snippet is running, is it running on just one server, like Spark agent, or is Spark clever enough to sort of split your data set up for you and run it concurrently on lots of separate servers?
Yeah, so Spark will load chunks of the data onto the different workers so that it can like be each of the different workers can be working on separate parts of the data in parallel. This is interestingly part of the advantage of having this like lazy evaluation model, that it's able, from what I understand, can build this like graph of computations that it's able to then like kind of intelligently allocate chunks of work across the cluster as needed.
That's really cool, thank you.
Thanks for the talk. How does Livy and related software integrate with custom-made scripts and other analysis tools that people might want to use? As in, if, for example, data scientists have their own analysis script and their own analysis methods, can those be integrated in the workflow of Livy, or would those have to be rewritten with the available methods in Livy?
Well, yeah, basically I think if you could use, for instance, in this code snippet, you could like just read your script in as text and dispatch it off to Livy in this way. Or I think if you're doing some like data science, then probably the kind of more interactive like scenario of Jupyter Notebooks is probably easier for doing some interactive analysis. But I would envisage that if you were doing things as a like repeated, like this, you wanted to run the same script repeatedly, you would probably wrap it in something like this. So yeah, you can basically with a relatively small amount of kind of code wrapped around your script, then you can dispatch your code off to run on Spark and then wait for it to finish. Yeah. I'm not sure if that answers your question.
Any other question? I have one, if no one else wants to go. So Spark MLlib, how does it compare with scikit-learn in terms of variety of algorithms and whatnot? I
haven't done an extensive comparison. We're actually just starting a project at the moment. Spark is something that's still relatively new to us, at least in the consultancy at ASI, for like processing these very large data sets. But it does seem to be like it's more full-featured than I expected up front. I'm sure that it's probably missing a lot of the stuff that scikit-learn has, but especially for certain applications like natural language processing, it seems like it has a lot of the kind of core features that you would want.
Thank you. One more question? Nobody? Yeah.
So was it Parquet, that bit with magical? Is that a predefined format, or can you describe the format of the data yourself?
Yeah. So Parquet is a format that I believe has been like written specifically for Hadoop and Spark clusters, or at least inspired for them. It's like a binary columnar data format that I think, basically optimized for doing these kinds of like map-reduced jobs and distributed computation. So if you've got some data source that you're getting in a more real-world scenario, it's likely to be in something other than Parquet. But it seems that if you want to keep some of that data in the longer term because you plan on doing some repeated analysis, then storing it in a Parquet format is just going to like make your like I/O part of your application much more efficient.
Thank Andrew one more time.